Alright, because okay, we have to, sorry, late start today. So let's plow straight into it. No song and dance today. We're going to go some more work on the dating side. Woohoo! So we finished implementing the profile class in the last lecture, and I actually tidied it up a little bit. I had a couple of syntax errors in there, but I just fixed them up, and it now compiles. So, but that doesn't, just because our code compiles doesn't mean it tells us that it actually does what we want it to do. So what I'm going to talk about a little bit today. So we've just sort of been through the first 4 stages of programming, where we went from the requirements to sort of general vague requirements to a more specific specification. We worked that specification up into a design of what objects we were going to have and how they were going to interact with one another. And then we turned that into an implementation, or at least a partial implementation. We've implemented the profile part of that. And as I've said before, while these stages are listed in order, we don't necessarily start at the beginning and just work through to the end and finish. It's generally an iterative process of design, implementation, testing, debugging, going back and around until you've got something that does what you want. So given that we've implemented part of our code already and we think that it's nice and finished, we should move on to the next stage, which is actually testing our code and checking what it does. So testing. Testing our code is basically a matter of making sure that it does the right thing in every circumstance. Now we can't, it's tempting to think as soon as our code compiles that it's correct, but just because, that's like saying just because your grammar is correct that your essay says what it's meant to say. It's not true. Your essay could be complete lies with perfect grammar, right? This program could be perfect syntax but completely wrong, do absolutely the wrong thing. So we have to test it. We have to actually make sure that it's doing what we want. And even the best coders have to test their code, because nobody makes code work right the first time. We always make mistakes in what we do. The problem is we really want to test our code for every single possibility. We want to think of everything that could happen in our code and make a test for that. The problem is, of course, that our code could have a million different things happening, because especially when we consider all the different input values that could go into our code, there are so many different ways in which our code could be used. So what we really need to do is choose our test values cleverly so that they cover all the important cases. And so it doesn't make much sense, for example, in our profile code, it doesn't make much sense to test it. If I test it with one username and I test it with another username, I could keep testing different usernames forever, right? But that probably isn't going to tell me anything. We've got to actually choose things wisely. So if I've created a profile with one username and then I test whether I can get that username back again with the getName thing, that probably tells me enough information. If I do it once, it's probably going to work for all usernames, because there's no special cases for different kinds of usernames. Whereas if I test my profile thing for one date of birth, well, it might work with one date of birth and not with other dates of birth. And so we need to basically choose enough test values to gain some confidence that our code is actually doing the right thing in as many cases as we can. Of course, when we choose test values, we can't just stick them in and look at the answer and say, oh, it gave me an answer, that must be right. We also have to know what the correct response we expect is for it to get back. So a simple example would be for our code, for our profile code here, we have a username. When we create a new profile, we provide a username, and then we have a getUsername method which should return that username. And so one way of testing this would be to come back here and say, okay, we've compiled that. I'm going to create a new profile. I'm going to give it a username, Malcolm. No, actually, no, I'm going to need to give it a date. This is annoying. Oh, in fact, I don't know how to do that. Huh, there's something I don't know. Oh, that's really going to put a spanner in the works. I don't know how to create a date in... Okay, let's not do it that way. That's going to... I can't... that's going to be a problem because I can't actually type a date in here. How do I do this interactively? I didn't practice this before we came to the show. I don't know how to create a date in BlueJ. Oh well, that rather stuffs that up. That's going to put a thorn in our side. Anyway, I can create one in code, but I can't create. I'm going to do it in code instead. So we'll just say test class, and what I'll do here is I'll do the test in code rather than interactively. So I'm going to say test. I'm going to make a method, public void test test name, and what I'm going to do is create a new profile. So first of all, I need to create a date. Let's just say the date is today. So that's an easy way to create a date. New date. And then I say profile, and we have a profile, and we say is new profile. And we said there were two parameters. One is a name, and one is the date. And we're not going to worry about the date, but we have to provide it with some date because otherwise it won't work. So we create a profile. And then I need to say, okay, so I gave that profile the name Malcolm. So now if I say profile.getName, profile.getName, right? So then if I do this, if I get that result back and stick it in a thing, right? Now, whoops, I just broke everything. There. So if we get. So I've made a profile, I've given it the name Malcolm, and then I've called getName to get that back again. Now, the name that I got back should be the same as the name I put in, right? So this test, so what we could do here is say if name dot equals Malcolm, which is the name we put in, then system.out.println success. Yay, it worked. Otherwise, system.out.println println for however you spell println. Failure. Right. So we can actually. So this is testing our code, and it says, okay, well we put a name in, and we should get the same name back. And this is the simplest functionality of our program, is if we create something with a given value, then the accessor should return that value. And so what we've done is create something with a known value Malcolm. We get back a value from the getName thing, and then we check whether the value that we get back is equal to the value we expect it to be. And if it is, this test succeeded, and if it isn't, then the test failed. You can do this by hand, except that in this case we had to provide a date, and I couldn't provide a date by hand. Which is something I should have thought of in advance. So now I could, if I wanted to, I could make another test like this. So now I can actually run this. Let me compile that. And now we have, compile has got a bug. What do you mean a bug? Class date. Oh, import. I always forget the import statement. java.util.date. There we go. Okay, we compile that. What are you complaining about now? Has no, get username, not get name. Okay, so it helps if you actually write your tests correctly, first of all. Oh, what's your problem now? That's equals. Okay, and eventually it'll compile, yay! Okay, so our test actually is right now. Good. So now if we create, now if we just create a test, there's a new test object, and that test object we can run test name, and it prints success. So the getName method on our profile works, or at least it works for the name Malcolm. Now maybe I've made a getName method which always returns Malcolm, in which case this test doesn't actually tell us whether it'll work for every name. But it's probably reasonable to expect that I haven't done that, especially since I know I haven't done that. And so I don't really need to test it for a bunch of different names. I could, if I wanted to, I could write more tests like that, which say, so if we edit that, I could make this test name 1, and I could add here test name 2, second test, test name 2, and I could test that if I put in the name, what's a name? Whoops, wrong button. What's another name that I could use? If I put in the name Morgan, I should expect to get out the name Morgan. There we go. And if we run that, we'll probably find that that test works as well, hopefully. Now, well, that test won't because I put Morgan up there and Mogren down there, and so that'll actually fail. The problem with writing tests in code is if you get bugs in your tests then rather than in your code, it can get confusing. So the important principle here is we have a piece of code which is creating a profile and then getting a username, and then we have an expected value that should, an expected behavior from that code, and so we have a test which checks that the code is doing what we expect it to do. Now we've got to know in advance what the code, what we expect the outcome of the code is. If we don't know what the code's going to do, then there's no way for us to test it because we haven't got anything to compare against. Now in this case it's not really necessary for us to have two tests there, so we'll actually get rid of that second one. But we might also want to test the age, we might want to test the star sign, we might want to test all of those things. So when you're testing your code, you can either do this by hand, in which case you go through your code and run every single method and run it with different parameters and see what the answer is and check that every answer is the same as the answer that you wanted. But obviously that gets rather tedious, and especially because we need to retest our code every time we make a change to it. Because it's very, very possible for bugs to appear in your code when you change something that you thought was completely unrelated. That happens so many times. You think, you've got one part of code and it's working right, and then you go write some new code somewhere else, and somewhere along the line you accidentally break the code that was working previously. So what we really need to do is every time we change our code, we need to run all our tests again to make sure that they're all correct. Now doing that by hand is very tedious, and you'll end up not doing it because you'll just test the new things that you did and then not go back and check the old things. So the best approach is what's called unit testing, which is what I was just doing in the code, where you actually write code to do the testing for you. So you write, as well as writing the code that you're implementing, you write another set of code which does all the tests for you, which says, okay, if I do this with the profile, I expect to get this result. Do I get the right result? Yes, I do. Okay, I keep going. And then when you've changed your code, all you have to do is then run those tests again, and they'll hopefully print out success, 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 and you know that everything works. If suddenly one of them turns up failure, you know you've broken something. And so it's much more useful to do this sort of unit testing. And I tell you, well, I didn't learn about unit testing when I initially started programming, and when I wrote my programs, I would just test the thing that I implemented and then go on and implement some more and test that and implement some more and test that. And then when you finally come to run your entire system, you realize that it's broken and you don't know why. These kind of unit testings where you actually set up code to do the testing for you is really, really useful because it means that you can run your tests and check your code every single time you change it. You can just test it again. And it's much, much easier to find bugs when you do that because you're always testing your code on every little change rather than way down the track when you've changed a whole heap of stuff. But in general, the process of testing, I'm not expecting you necessarily to use unit testing at the moment. It's a good practice to get into. But at the moment, you should at least be making sure that you're doing rigorous testing by hand, trying to test all the different ways in which your code could fail. If we look at, to think about what kinds of tests you should do, think about the different paths that your code could take. So for example, if we look at the getAge method, there are basically three different ways this code could run. We could do this first statement and skip both of these two and return the age. We could do the first statement and then execute this one and then return age, or we could do the first statement and then execute this one and return age. So at the minimal level to test this is correct, we need at least three examples. One where it goes straight through, one where it runs the first part of the if statement, and one where it runs the second part of the if statement. So we need to test every alternative in our code because basically we want enough test cases that every line of our code runs. And if we just test this with one value, then some of these lines will run and some of them won't. So we want enough different test values so that all the different cases in our code get covered by our tests. This is really vitally important. It's very easy to leave out certain cases and then not realize until much later that there's a bug, that we got a bug in here somewhere and that this test doesn't actually do what we want. This part of the code doesn't do what we want it to do. And we never tested it because we didn't write something there. The other thing is every time you find a bug in your code, you should add a test which makes sure that you don't make that bug again. So if I wrote this code and found somewhere along the line that I had a bug in here, I would then have to add a test to my set of tests so that I knew that I could test for that bug, just in case somehow I made that bug again. Even though I fixed it, I should always test that I haven't done that again, made that same stupid mistake. Because the number of times you'll do that, you'll fix something and then you'll unfix it somewhere later down the track. And you need to make sure that you never unfix that. So if you ever do unfix that, you should have a test there that will tell you that. So the idea behind testing is getting as much coverage of your code as possible, making sure that every important piece of your code is tested. One of the good ways of doing that is also by thinking about edge cases. So for example, in this case of a birthday, we've said that your age is the difference in years, but you subtract one if your birthday is later this month or is later on in the year. But what happens if your birthday is exactly today? What should this code do? Should it say, if my birthday was today, am I 37 or 38? And so if it's your birthday today, presumably you are the second of the older of the two values. But you should make sure that you have a test to test those edge cases. Because if your code's going to go wrong anywhere, it's going to go wrong at the edges. Often you'll have the right answer over there and the right answer over here, but the answer exactly on the boundary will be wrong. And they're very common kinds of bugs to make. And so you should always test the boundaries. The other things you should always test is you always should test the extremes as well. So what if a person is 0? What if I'm asked, this profile is for someone who was only born yesterday? Does my code, or only born today, does my code still give the right answer? Does my code give the right answer if it's for someone born 100 years ago? So generally, what you want to test is test every kind of path in your code, then test the really big answers and the really small answers, and test every boundary between two different answers. So where your code shifts from giving one answer to giving another answer, you should test those places as well. Testing is really an art. You learn it over time. But the more confidence you can have, you test your code rigorously and in all the different cases, the more you'll know that your code will actually work. Obviously, you can't test everything. There's no way I could test every single birth date. That would just take forever. So I've got to make some compromises. So the nice... so BlueJ includes a library called JUnit, which we're not going to go into today, but I'm just going to let you know about it and show you at least how to use it from the testing point of view. If you go here into Preferences, Miscellaneous, there's a Show Unit Testing Tools option there. That's normally off, but if you turn Unit Testing Tools on, then what you'll see is this little thing down here, which allows you to run tests, and you can create things like this, which is this basically gives you a whole bunch of back support for creating unit tests. And I'm not going to go into how you do that, but this is essentially what one looks like. These are my unit tests for the profile class. And so here's a test for testing that the name thing works, and there's a couple of tests for testing that age works, and tests for likes and blocking. And so I've basically written a whole bunch of different cases, especially for the blocking thing, which is reasonably complicated. I've written a whole bunch of different cases about, well, what happens if I block somebody and then block them again and then unblock them, will they become unblocked correctly, or will they still be blocked? And various, so I've come up with a whole bunch of different cases about how you might block and unblock people, and in every single case I have these assertions which says, well, what do we expect? And in this case, if we block, so for example here, if I block Claude, then I expect his profile to be blocked, but I don't expect my profile to be blocked or Morgan's profile to be blocked. If I block him again, I expect him still to be blocked, and neither of us blocked. But then if I unblock him, he should become unblocked. So I can't block someone twice and then, if I block someone twice, unblock them once, they should become unblocked, right? I shouldn't have to unblock them twice as well. So that's what that test says. It's kind of hard to read, but the JUnit basically gives you an easy way of doing this. The nice thing about this is that rather than printing out a whole bunch of success and failures, it actually looks like this. Woo! It actually gives us all the individual tests, and you can see which ones succeeded and which ones failed. So we had 3 failures in our tests. In particular, if we look here, we expected the age to be 30, but it was minus 1800 and 1870. So there's a bug in our age method, because I tried to do somebody's age, and I've got the year out by a large degree, so something's wrong there. There's also a bug in our blocking method. In that one that I showed you, if we actually block somebody twice and then unblock them, they still remain blocked. So there's a bug in there as well. So by testing on a lot of different values, we've actually managed to find some problems in our code. And these are problems that I didn't know when I was writing it on Tuesday. These are problems that only turned up when I started writing these tests. Now, if we wanted to go and find out what they were, I'm not going to debug all of those, but I will look at the one with blocking. So, don't worry about how to write JUnit tests for the time being. I will provide you in the COMP1400 assignment this time. I've actually provided you with some JUnit tests for your thing. So you should be able to just run those in that same way of pressing the run test button, and it should tell you which one succeeded or failed. Whether that's helpful or not depends on how well you can actually understand what I was testing for. But you should at least play with that and see how those tests do it. I've only written a couple of tests for that assignment, so if you really want to be advanced and rush ahead, you can read up on JUnit and write some of your own tests in there as well. I strongly advise it if you feel up to it, but obviously we're not expecting you to do that at the moment. We'll talk more about using JUnit hopefully later in a later lecture. We'll get around to actually giving you like a guided tour of JUnit and how to use it. It is a really useful tool, and I recommend you learn it, but we won't be testing you on it, so don't worry about that. So once we've found some problems in our code, we need to actually fix them, right? And so that's the process then of debugging. Thanks. So debugging actually isn't just, it's actually broken down into several stages. The first part of debugging is really working out when does the bug occur. So under what conditions do we get that bug? And so that's the reason why we're doing testing, and we're testing as many different things, is that we've worked out that there's a problem in our blocking code, but we've actually gone further than that and worked out, well, there's a specific problem in our blocking code when we block somebody twice and unblock them once. So if we didn't test all those things individually, we might just have some situation we don't understand where blocking is not working and we don't know why. Here we've managed to break it down by doing testing on smaller and smaller cases. We've managed to break it down to a specific problem. So the first and most important part of debugging is actually working out specifically when does the bug occur. The second thing is working out where your code is going wrong, what part of your code has the problem in it. The third part is then working out what on earth is causing the bug, and hopefully if you've managed to locate it, you can sort of find it at a couple of lines, and you then have to understand what that code was doing and work out why it's doing it wrong. And then the final thing is actually fixing it. So to identify problems in your code, you've got a test, it failed, it didn't do what you want it to do. The most important thing then is to actually, or worst case, you forgot to test it and one of your users has come to you and said, my code crashes when I do something. The first thing is to actually be able to reproduce the bug. Now, if one of your users is having a problem with your code, they might just say, my program crashes when I try to print. And that doesn't tell you much, because when you try to print, it works fine, right? And so it's not about just printing in general, it's about some specific conditions of printing. Maybe it's because they've chosen to print in landscape mode and you've been testing it in portrait mode. Maybe it's because it's in landscape mode and they're using a color printer. Maybe it's because it's in landscape mode, in color printer, and a certain model of computer with operating system from whenever, right? So bugs are often reliant on a very small set of conditions. So in the code you're writing, they're probably going to be fairly simple. But over time, the more sophisticated programs you write, the more your bugs are going to be narrowed down to only occurring once in a blue moon under very strange conditions. Some bugs can be really, really hard to find because when you do it, it crashes, but when I do it, it works perfectly. And then it's a matter of working out, well, what's different about your computer, the way you're doing it to the way that I'm doing it. And sometimes it's very hard to work out what the difference is in those cases. There's some lovely stories from computer programmers about some of the weirdest problems that they've ever had, where bugs turn out to be some of the most esoteric things, based on the phase of the moon and the things like that. And literally, there has been at least one case of a phase of the moon bug, a bug that only occurs when the moon is full, and that was because of some piece of code that looked at the time of the month. But hopefully in your code, you'll be able to isolate it down to a specific case of what's going wrong. So in this case, we've found that the code specifically doesn't work when we block someone twice and then unblock them. That's a fairly specific example. And we can do that reliably. Every time we run that test, it does the same thing, and so we know that that's probably where the bug is. We know what input values are causing the bug, and we know that there are other input values which work fine. So we know it works fine. If we block somebody and then unblock them, it works. But if we block them twice and then unblock them, it fails. So we've got two different cases, one which works and one which doesn't. And that gives us more leverage to find the bug, because we know that some things are working, but something else is not working. And so we can try to compare what's going on in those two cases. The closer we can get between dividing up between those cases that work and those cases that don't, the easier it's going to be to locate our bug. So if you just say it kind of works sometimes and doesn't work other times, it's kind of very vague. The more you can bring it down to two very similar cases that if you just change one little thing, you cause the bug, you make the bug to happen or not happen, then the more likely you are to be able to find what's going wrong. So a lot of the art of debugging is actually doing that process of taking a problem which is initially vague and saying, well, okay, what if I try this? Okay, that causes the bug to happen. Okay, well, what if I change it so it's that? Okay, that causes the bug to not happen. What if I bring this a little bit closer? Okay, it's still happening. This is a little still not happening. And then I can say, okay, the bug must be somewhere in between here and here. Whereas if I'm still out here, I say, well, I don't know, the bug could be anywhere, if this is all I know. So it's about narrowing that gap between the things that work and the things that don't work. Once you sort of know how to make a bug recur, how to reproduce a bug, then you need to work out where in your code that is happening. And now, once you know, if you have an idea about what's going wrong, you should at least have some idea of where the bug might be. So in this case, I know that the bug is happening when I block and unblock people. So I'm assuming the bug must be somewhere in my code, either in my block user code or my unblock user code. Either there's a bug in my block user code, which means that when I come to unblock somebody, I don't unblock them properly, or there's a bug in my unblock code. And so I have to go and look at those two things and work out where the bug is. So one of the ways you can narrow this down is by actually using the debugger you pick up if you have a case that you know fails, doesn't work, then you can use the debugger to run through it step by step and see what goes wrong. The important thing here is that you actually need to understand your code in order to do this. you can't tell if your code is not working if you have no idea what it's meant to be doing. So you need to actually be able to look at your code and read it and say, I know, okay, that line should do this. And then you look at what it actually did and you go, well, that isn't what I expected this line to do something, but it did something different. Finally, so the really important thing is you need to actually understand what your code is doing. New programmers like to try to fix bugs just by poking at things. If it doesn't work, you kick it. And kicking it generally means making random changes to your code and seeing what happens. You are not going to fix your programs by doing this. But I've seen this an awful lot in new programmers. So rather than try and work out what's going wrong, they just go, maybe if I poke at something and it'll just start working magically. You know, there is no magic. You can't just make bugs go away by randomly poking at them. You do have to understand what you're trying to do. And then the only way forwards is actually once you've worked out what's wrong, hopefully you fix it. And that is you replace the code that's wrong with code that's right. There really is no magic to fixing it other than finding out what was wrong and changing it to the right thing. So let's see if we can find this bug in our code. So we have, so we reckon there's something going wrong in our block user code. So let's go to this test. Here's the test which is failing. What I'm going to do is put a debug statement in there, and I'm going to now run that test again. Okay, and we've hit the breakpoint, and it's put up the debugger. I'm going to step through this. Okay, so we've created. So we know that creating profile works fine. So that seems to be okay, and we know all those tests work. So when we create a profile, nobody is blocked, and we've already tested for that, and we know that that's true. But we've got a problem now. We've just blocked a user once. We know that blocking a user once tends to work. So, but here we're blocking the same user for a second time. And so what I'm going to do now is where I was previously just stepping over these things, I'm going to use this button here, which is step into. Step into takes us inside that method. So inside the next statement. And so we press that, we jump, and now we're inside block user. And now we need to check that this is actually doing the right thing. So here is, where is it? Here is our, we haven't got much space. Let's make this bigger. Here is our list of blocked users. Let's see who's on that list. Okay, that list currently just contains Claude. So that's right. That's what we expect it to be, right? We've blocked Claude, and so Claude should be on the list of blocked users, and he is. And so that's the right thing. We also, so now we block, so now we execute this. So we, whoops, go back to the debugger, wherever I put it. Where did I put the debugger? Debugger, there it is. So now we execute the next statement. And now what should be, now if we look at what's going on here, we've now got two things on our blocked user list. And if we have a look at the data, we've got Claude twice on our blocked user list. And now this raises, this is where we realize that something's going wrong. Because we've blocked Claude twice, his name appears twice on the list. And that isn't the right thing. We should only have each user on there once already. And so now what happens when if we return, so if we continue stepping through our code, we come back to here. So we've now blocked Claude twice. Sorry, not enough room on the screen to show everything at the same time. We've blocked Claude twice. So now if we step through that, and now if we step into the unblocking Claude, here's our code for unblocking. Okay, so we go through, we're unblocking Claude. We've just found an entry. So the first entry on the list, we found an entry. The user we're trying to unblock is Claude. The first entry on our list is Claude. So we're going to remove that entry. And now, oh, go away. Where was I? So now we've removed Claude from the list, but if we look at our list, Claude's still there. And the reason why Claude's still there is we removed the first occurrence of Claude, but the second occurrence is still on the list. So remember lists can have duplicates on them. And our program has just looked for the first instance of that name and removed to the first instance and has left the second one there. And so if we block Claude twice, we get Claude's name on the list twice. If we unblock Claude, we just find the first instance of Claude's name and get rid of it. But we've left with the second one there, and so Claude is still effectively blocked. So there's the bug in our code. We now have to work out the correct way to fix it. Now there are a bunch of different ways we could fix this. Terminate that, close that, go away. There's a bunch of different ways we could fix this. One way we could fix it is we could make this, we could make unblock user remove every instance rather than just the first instance. So we could allow Claude's name to be on there twice, but we could remove it. We could remove all of them. That's a bit silly though. There's no real need to have Claude's name on there 2 or 3 times. And so what the correct thing to do would be have something here which says if my blocked users dot contains username. Actually, we want to say if my block users does not contain username. So if we haven't really covered Boolean expressions, but that by putting an exclamation mark there, we're saying not. So that now says if Claude is on the if Claude is already on the blocked users list, skip this code and don't add his name twice. So now if Claude is not on, so that says that read the exclamation mark as not. If it's not true that Claude is on, the blocked users has Claude's name on it, then we can add Claude's name. So if Claude is already on there, we don't add him a second time. If we compile that and now run our tests again, we'll remove that breakpoint. Go away, go away. How do we change? No, that does. What is it beeping at us for? Why is it beeping at us? Ah, there we go. Go away. Yep, brilliant. Now if we close that, we run our tests again. Yay, our test has passed. And we haven't made any of the other tests break, which is also important. Because by fixing that one thing, we might have broken something else. And so by having these unit tests where we can rerun all the tests again, we can see that we haven't made anything else break. Now we've still got to fix the bug in age, but I'm not going to do that right now. But at least we found and fixed one bug in our code. So now I use the unit testing is really helpful there because it allows us to run those tests automatically. Probably for what you're doing, because we haven't gone, you can write your own unit tests in the sort of way that we've been doing here, where you just get the value back and test and use an if statement to test out and print out whether true or false. Or you can just run tests by hand. Probably at the level you're doing it, you might just want to run your tests by hand, but I really encourage you to test your code. Unfortunately, the process of testing and debugging is only one of those things you can learn by practice. You will find things wrong. There are sort of general principles for how to do it by the main principle is that idea of breaking it down into the smallest possible place where the bug could possibly be. But really it's an art that you can only learn by lots of practice. So I encourage you to make mistakes and then fix them because that's the only way you're going to learn. Right, before I told Claude we'd talk about, we don't have time. I told Claude I'd talk about the rest of the dating site thing, but we don't really have time. And this is going to be my last lecture with you guys, so Claude is going to be taking over from next week onwards. So it's been fun, it's been exciting. Do you have any particular, so now's a good time at the changeover to find out whether there's any particular, I'm going to annoy, there we go. Things that we need to, we've covered an awful lot very quickly, I'll admit. So if anyone's feeling lost and behind, that's kind of okay because we're going to take a stretch of time now to kind of revise and make sure that you all are up to where we're up to. So we've basically covered almost every part of procedural programming. You have enough now to go out and write programs that do almost anything. There's a little bit more that we're going to teach you about object-oriented programming, but really what you want to learn now is the skill of how to use these pieces to do what you want to do, to solve problems. And so Claude's going to spend the next couple of weeks talking a little bit more about, or revising some of the concepts we've been over, and talking a little bit more about how to do problem solving with these tools. So I guess right now is a good opportunity for you to let us know what things you would like us to revise. You can yell them out now, but probably most useful would be if you could mail them to us in the class account. If there are particular, or talk to your tutor about it and get your tutor to give us feedback on it. If there are particular ideas that you're just not getting, now is the time for us to solve that problem, because we don't want to dive into some more advanced stuff if what we've said so far isn't working. If everything so far has been really easy and great for you and you're plowing straight ahead, then that's really good. But yeah, we want to take a moment to sort of reflect and make sure everything's going well. Yep. So hash maps. Oh yeah, so hash maps are the one thing. Well, okay. So hash maps, I probably was what I was going to spend the next couple of minutes talking about. So if we have about 5 minutes left, I can talk about hash maps if you want. I can do it quickly. Does that sound good? Any other questions about stuff? Do you want? Okay, well, I'll dive into hash maps, especially because I think Claude has put hash maps in assignment 2. So you should probably tell you a bit more about that. Oh, one thing I wanted to say before I talk about that. I've just finished marking assignment 1 for COMP1400, and I don't know how things are for the Infosys, but I noticed certain sections of code that looked remarkably similar from one entry to another. First of all, we're not stupid. We can tell when you're copying and pasting from one another, especially when you make identical mistakes. If you're going to copy, please copy correct code. Don't copy wrong code. God. But we're not stupid. We can tell when you're doing it. And you have signed several things saying you will not plagiarize. And the University Code of Conduct does have significant penalties for plagiarism. Now, I'm not here to wield a big stick and tell you all you're bad. I am here to tell you you're not going to learn anything just by cutting and pasting code that you don't understand. And 60 or 70% of the assessment for these subjects will be in exam conditions where you can't copy off the person next to you, or at least we hope you can't. So you do make sure that you understand the code that you're submitting. I really don't mind that if you help one another. Actually, I think it's a good way for you to learn by helping one another. But I do mind if you're just copying code and sticking it in your assignment and you have no idea what it does, but you just want it to submit code that's right. So this time round, I'm not taking any action on it. But in future, I would really like to see code that is your own code rather than somebody else's. We have in the past done interviews where we've asked people in these situations to explain the code that they've written, and it's awfully embarrassing for everybody when you sit down there and say, oh yeah, I wrote that code. You go, oh, well, what does it do? And you go, yeah. And I sit there and stare at you and you go, and then you go, you copied this code, didn't you? Oh, no, I wrote that code. And you go, oh, you wrote it, you have no idea what it does, right? So please don't copy. It's just embarrassing for everybody. And I don't want to have to go through that, and you don't want to have to go through that. But and it won't help any of us learn, so let's not do that. All right, hash maps in 5 minutes before I run away. When we were doing let's look at the dating site, back to the dating site example. We wanted to say that we had a dating site object which contained all the profiles. So we've got profile objects for thousands of users because it's a massive dating site. And we want to then have one container that has all that stuff in it. So what we want to do is have a dating site object which is going to give us a way of looking up individual profiles. And in particular, we want to look up profiles by name. So there are a bunch of different ways we could solve this problem. We could have just have a long list of profiles. And when I ask for Morgan's profile, I could go through every profile in the list and look at its name. And you know, profile 1, is that Morgan's profile? No. Profile 2, is that Morgan's profile? No. And so forth, until I found Morgan's profile somewhere, or I got to the end of the list and it wasn't there. Now that would work, but it wouldn't be very efficient. And especially if we had thousands or millions of profiles, it could take forever for me to find Morgan's profile. Or worse still, if I find out Morgan doesn't have a profile, I've got to go through all million profiles in order to establish that that's true. A better way is to use a hash map to provide this lookup. So if you remember, a hash map is a thing that whereas lists and arrays are indexed by number, hash maps are indexed by another type. And so we can use a hash map here to index everybody's profile by their username. And so we could have a hash map like this of my profiles, which is a mapping from strings, that is their username, to profile. And then using that, we could provide a method like this, which is getProfile, which allows us to get somebody's profile. And I'll just quickly show you how we could write that. Where's BlueJ gone? Oop, what are you doing? BlueJ, what are you doing? Oh, there it is, dating site. We're going to create a new class. We're going to call it the actual dating site class. Here it is. We're going to, so this time I'm going to remember Java import java.util.hashmap. It's funny that Claude used hashmap because he was the one who told me not to teach you hashmap. He said, they don't need to know that yet. And so I thought, yeah, I won't bother testing on them. I won't put it in the assignment. And then he wrote an assignment which uses it. Anyway, so like any other class, we want to have a hash map of profiles. So we can just say private hash map, and we'll call it my profiles. And now hash map, like an array list, has this type parameters inside the angle brackets, but it has two. One is the type of the key, and the other is the type of the value. So the key is the thing that we're indexing with. So in this case, we're indexing by username, and username is a string. So we have the first thing is a string, then we have a comma, and then the second thing is what kind of value we have in our map. And so this is profiles, right? So this is a map that the index is a string, and the value that we're looking up is a profile. So then we can create a constructor, public dating site, dating site, and we say in the same thing we have to initialize this. So we say my profiles equals new hash map string profile empty braces. Empty parentheses. So that creates an empty hash map. There's nothing in it, right? Now we want to add some code to add a user. So we'll say public void, because this is a mutator method. It doesn't have to return anything. Add profile. And we're going to have a string that's no, actually we're just going to have a profile. There we go. We're just going to add this profile, okay? So we've created a profile for somebody, and now we need to add it to our site. Now the way that we add this is we're going to first of all ask the profile for its username. String username equals profile dot get username. So I've been given Morgan's profile. So I ask, it has Morgan's username stored on it, and so I ask it for Morgan's username. And now I'm going to add that to my hash map using that username as the key. And so I can say my profiles dot add username comma profile. And what I'm doing there is saying, creating a new entry. The index for that entry is Morgan, and the profile for that entry is this Morgan's profile that I've just been given. And so now, in terms of an illustration, if I brought some pens, oh nuts, what do I do with my pens? There we go. So now initially we had an empty hash map that didn't have anything in it. What I've just done is added a new one. The key, it has a key and a value. The key is now Morgan, and the value is this profile over here. which is Morgan's profile. And so the value is a reference to that. And this has Morgan's date of birth and star sign and everything on there, whatever they might be. So now what I can do, and if I added another profile, so I had here a profile for me. So this is my profile, Malcolm. And I want to add that. What I would do is call this, so I call add profile with this parameter. I then get this name from here, so this is my name. I copy this name into the variable name or username. So so that value goes into there, and then I add. So this is my profile. This is my username. I can then add this profile to here, which then adds it with that index. And that one will point to that profile. Right. So it's disappeared off that screen. What? Oh, I didn't realize that screen wasn't on. That's interesting. It should be on. So I can add entries like this. Basically, all I need to do is say, this is the key that I'm going to use to look up that entry, and this is the value that I want to store at that spot. Now, because these things are objects, remember, objects are always references. So the object's floating out there in space. Morgan's profile is somewhere out there. The thing in my map is a reference to Morgan's profile, an arrow pointing to the profile. Okay, so I can add as many profiles like that as I want. If I come up with a new profile, the problem here is every username has to be unique. So if I had a second profile here that was also, the username was also Morgan, if I added the second profile, it would overwrite the first, because if I add a profile, oh, I just realized there's something wrong. Anyway, I'll get to the second. If I add, a hash map has a unique value for every key. And so there's only one value that has the key Morgan. And that's going to be this one. If I put in a new profile that also has the name Morgan, it will replace that one. And so if this was a different person but also called Morgan, so we had two profiles for people called Morgan, where's the thing? If I went to add, so I've already got one Morgan in my system and I went to add that one, what I would actually do is replace that one with that one. And so the old Morgan would be lost. So in a hash map, we have to make sure that the keys are unique, that we don't have repeated keys. If we want, we run out of time, but I'm going to do this anyway, just to get something, if we want to get a user by get a profile by username, get profile. Oh, I've made a mistake here, by the way. That isn't add, that's put. It's one of those confusing things. Lists, you add things to lists, you put things on hash maps. Go figure. I don't know why. So put. You should look, if you really want to verify what this is, you should look it up in the API documentation. To get things off it, we do the reverse. We say my profiles dot get. Now we need a name that we're getting, so we'll have to ask for what name. That has to be a parameter. String username. We give it that username and it gives us back the profile. And what we want to do here is return that profile, so we just say return. Okay. So this is basically how we look up things. We use hash maps. We can look up things, we can add things by the put method, which sets the value for a certain key, and we can get things using the get method, which takes a key and returns us the value that's associated with that. So if we get the profile for Morgan, in this case it would return that one because that's the one that's currently in the table. If we try to get the profile for a name that isn't on the list, it's going to return null, which tells you that there is no thing there. So if we say get profile Malcolm, it's going to look on here, it's going to look for the entry for Malcolm. There is no entry for Malcolm, and so it's going to return us the null object, which is the nothing object to represent that there's nothing there. So this is basically, it's the same sort of process as having a list, except that rather than indexing by number, you're indexed by anything you want. It can be a name, it can be any other kind of object, anything can be the index. Usually you'll probably use it for indexing by name. In the assignment, I think he asked you to index by, I don't remember what he asked you to index by. The other use for these things is when If you have an index by number, but not your indices don't all count from 0 up to 1,000,000. So, so if you're indexing by, account numbers, not every account number is in there. You don't necessarily, if you're indexing by Visa card number, you don't want 10 billion things in your array, since there probably aren't actually 10 billion different customers. So you can just index by certain integers. But if that doesn't mean anything, don't worry about it. That's me making up stuff all the top of my head. I've got to run. I've got another class. Hopefully, if you have more questions on that, Claude can tell you about it. I had fun teaching you guys, and I will see those of you who are in my tute. I will see you later. Oh, that really isn't necessary, but thank you all the same. I hope you all do well. I look forward to marking your next assignment.